All right, so the next unit that we're going to be doing in Trig, we need to understand what a radian is. And as I've said previously, a radian is just another unit of measurement for an angle. So we're going to look at how do you convert from degrees to radians and back again, radians to degrees, in section 16.3. So first of all, let's define what a radian is. Like I said, it's a type of angle measurement, but how do you figure out what an actual radian looks like in your circle or with your angle? So I have this circle drawn here with the center at O, and you have an arc. When you connect two radii, you get this arc. And you also have an angle right here. So what they have decided to use as the amount that a radian would be is whatever angle is formed here when the length of this arc is exactly the same as the radius of the circle. So for example, if this radius here is 8, and this is 8, then the length of arc AB is also 8, then the angle that is formed is considered to be 1 radian. So radians are actually really large. And you can think about like how many radians would you be able to actually fit into a circle. It's not a lot. You know, in degrees you can fit 360 degrees in a circle. Radians, it's a little bit more than 6 radians in a circle. So it's a very different way of thinking about your angle measure. All right, so here's an example. What if I told you that the radius of a circle was 4 and your arc length is 6, and I asked you to figure out the measure of the angle that is created, but you need to find it in radians. Okay, so if you think about it, this part is 4, this part is 4, but this is 6. And so since this arc length is more than the radius, we know it's going to be more than 1 radian. But by how much? How would you figure that out? Well, every 4 units that you would move along for the arc length is going to be considered 1 radian. So if we go 4 units from A to B, and then we go a little bit more to get to 6, we're actually going 2 more, which is half of 4. So you can think about theta as taking the length of the arc, which is 6, and dividing it by the length of the radius, which is 4. And that gets us 1.5 radians. Okay, so very, very unusual, not very comfortable right now, I'm sure. But eventually you will get comfortable with it. Okay, so let's talk about a formula to figure out the measure of an angle in radians. What you would do is, just like we did before, is you take the length of your arc and you divide it by the radius of your circle. So here's what that would look like. Theta would equal S over R, and S represents the length of your arc. Okay, so what if our arc was actually the entire circle going around one complete rotation? What would the angle be in radians? And we're talking about the angle of 360 degrees, so going an entire way around the circle. So using this formula, our theta would be the arc length, which is the circumference of the circle, divided by r. So that would look like this. We have theta would equal 2 pi r divided by r. Well, the 2 r's are going to cancel out, and we're just left with theta is equal to 2 pi. So what that means is 360 degrees is equivalent to 2 pi radians. Okay, so 360 degrees is equivalent to 2 pi radians. So if I wanted to figure out what that actually is as a decimal, you would take 2 and multiply it by 3.14159. You've got that button on the calculator you would hit, right? And you would get the most accurate answer. So you end up getting 6.28 something or other radians. So like I said, it's a little bit more than 6 radians for an entire circle. The thing about radians is there's 2 different forms that you can write them in. One is in pi form, which I have here at 2 pi, and the other is in decimal form. And you should be comfortable looking at radians in both forms and working with them in both forms. All right, so let's talk about now, based off of 360 degrees being equivalent to 2 pi radians, what 180 degrees would be in radians. So since 180 is half of 360, we would just take half of 2 pi, which gives us pi. So half a circle is equivalent to pi radians, which is 3.14 radians, right? And then continuing on, half of 180 is 90, so half of pi is pi over 2. And so that's how many radians 90 degrees is. Okay, so what we're going to want is a conversion factor, right? Something that we can use when they give us an angle in degrees. It's not one of our lovely quadrantal angles or anything special, 30, 60, 90, 45, 45, 90, right? Okay, so what we have here is that 1 degree is equal to pi over 180 radians. So you can just take this equation right here, divide by 180. You get 1 degree is equal to pi over 180. And then likewise, if we wanted to go the other way, 1 radian is equal to 180 divided by pi degrees. Okay, so let's actually see, what is 1 degree equal to in radians as a decimal? So you would take 3.14, divide by 180, and we get 0.02 radians. So 1 degree is what we're used to working with, but it's really small in relation to a radian, so it's only 0.02 radians. Likewise, if we go over here and we want to see what 1 radian is equivalent to in degrees, we take 180 divided by 3.14, and we get 57.3. So almost 60 degrees for a radian. Pretty interesting. Okay, so let's take a look at some questions that you're going to have to do to convert. All right, so we're going to have 2 different types of problems. One where they give you the degrees and you need to convert it into radians, and the other where they give you the radians and you need to convert it into degrees. So let's start up here. It says change to radians and to leave your answer in pi form and as a decimal rounded to the nearest hundredth. So we're going to have our answer in 2 different formats for the radians. So 210 degrees, remember our conversion factor, we would multiply that by pi over 180. And when you do that, you're just going to simplify this fraction that you get to leave it in pi form. So cancel the 210 and the 180 as much as you can, and you get 7 pi over 6. So that's 7 pi over 6 radians. And then it also asks us to round it to the nearest hundredth, leave it as a decimal. So to do that, now we're going to replace pi with 3.14, and you get this decimal of 3.67 radians. Okay, so let's try the next one, negative 32 degrees. So we still multiply that by pi over 180. This time simplifying, it doesn't come out as nicely. We get negative 8 pi over 45. Okay, and then we can multiply that by 3.14, and we get negative 0.56 radians. Still pretty small. Okay, so what do we do when the angle that they've given us is in degrees and minutes, and we still have to convert it into pi form and figure out the decimal value for radians? So the thing is, this 20 minutes is just a fraction of a degree. So what we need to do is we need to convert this into an improper fraction of degrees. So 20 divided by 60, so this is going to be 25, and 20 over 60. Simplify that, so it's 25 and a third, which reduces or converts into 76 over 3. So this is degrees, 76 over 3 degrees. And just like we did with all the others, we're going to multiply by a conversion factor, which is pi over 180. And we're going to simplify. So if we simplify that, we get 19 pi over 135. Quite messy, if you ask me. But still, that's what it is in radians. So the next thing to do is to convert it into the decimal form, which is pretty easy. Just replace pi with 3.14, and we get 0.44 radians. All right, so these are definitely the more complicated type of questions that you'll have to do. When you have an angle in radians that are in pi form, it's really easy to convert it to degrees. All you have to do is replace pi with the equivalent of it in terms of degrees, which pi is equal to 180 degrees. So you just replace this with 180 instead of the 3.14, and you'll get your degrees. So 5 times 180 divided by 6, we get 150 degrees. And over here, negative 7 times 180, you get negative, oh, I forgot my degree symbol, negative 1,260 degrees. Okay, so those are conversions. Next, these problems that you're going to see here should look familiar. We did these all back in Unit 1, only we did them with degrees, and now we're going to redo them, but in radians. Okay, so we're trying to figure out 1/8 of a rotation in the counterclockwise direction. Find theta in radians in pi form. Now, what I do not want you guys to do is to work out this problem in degrees and then convert from degrees to radians. You should be working out this problem solely in radians. Okay, if you don't do that, then you're not getting the practice that you need. Okay, so 1/8 of a rotation in the counterclockwise direction, well, counterclockwise first is positive, and an entire rotation is going around 360 degrees, which was, remember, equivalent to 2 pi radians. So we're just doing 1/8 of 2 pi. To simplify that out, you get pi over 4. So there's your answer, pi over 4 radians. Okay, next. Remember this question where they give you, this really should have been theta, whatever. They give you an angle in radians, and they want 2 clockwise rotations, and you need to find the angle that's coterminal to it. So if you recall how we used to do this problem, we would take care of our rotations first, and then add our angle. So 2 clockwise rotations, that's in the negative direction. 2 times a negative 2 pi, and then we add our angle, which is pi over 3. Problem is, now we have fractions. I know you guys love fractions. So this is going to be a negative 4 pi plus pi over 3. Convert it so that it has the same denominator. Add that together, and we get negative 11 pi over 3. Okay, so I really do not want to see you converting this into 60 degrees, working with this in negative 360 degrees, add the 60, and then afterwards convert it into pi. You will not be getting the practice that you need for that, and I will not be happy. Okay, so there you have it. That's your first introduction to radians. Hopefully that wasn't too bad. We'll be working with these extensively for this whole unit, and hopefully after that you'll be more comfortable with it. All right, that's it for now. See you later.